Okay, hi everybody. Today is August the 28th, 2024. For this content, it really didn't matter. And this is episode 5, or session 5, or video number 5. Anyway, just want y'all to know, putting this on the front of the video that's fixing to play. Thanks. Okay, hi everybody. So we're going to talk about using a small generator to power some of your house in an emergency situation. So, we're going to talk about electricity a little bit. So let's talk about how you define the different terms that you see on appliances and things like that when it comes to electricity. Now, most people are familiar with volts because you see it all the time. 12-volt battery, 9-volt battery, different kinds of voltage for different kinds of batteries. And you also see voltages in your house. 110 volt, 120 volt, 115. When you buy appliances and things, they have those names in there. Now, you've probably heard of 220 or 240 volts, 230 volts electricity also in your house. Typically dryers, electrical dryers, electrical water heaters. I don't know about water heaters, they might. But they've got 220 volts. Your air conditioning compressor outside, for those who have air conditioning compressors, centralized air, they have 220. Now, 220 in a house is typically 220 volts, and it's basically two 110 circuits. So normally you have a, let's see if I've got it right here. Once I had it. All right, I'm going to go get it. Pause this for a minute. So normally you have, for 110, you have 3 wires. Like this wire right here has got 3. There's a black, a white, and a green. And the green is what we call a ground. The white is a neutral, and the black is hot. Now, when you have 220, you have a 4th wire. I can't remember if it's red. I think it might be red. And so you got to make sure that when you hook them up to plugs and things, you got the right ones. But so when we're using this stuff, we got to make sure that we're doing it all right. And the thing is that when you are trying to get your generator to work, to heat, to run, and maybe power your refrigerator, your freezer, you've got a situation where a big storm came in. Now, oh my gosh, I got a generator, but I don't have a way to hook it up to the house. I didn't pay the electrician to go and install a special plug that works with my generator. I just got the generator and I've got some extension cords. Well, that's kind of a pain. And depending on the weather, what kind of storm it was and the weather outside, obviously if it gets hot and you don't have power in the summer, like in Texas, you kind of want the windows open and stuff. And you may want some fans running. And fans don't use very much electricity. They're very, very efficient, don't use hardly any electricity. And but there's a better way, or an easier way, of hooking up electricity to your house, just using a generator and an extension cord. So what you do is you have, first thing, before you ever add electricity to your house, any kind of power, you have to turn off the breaker, the main breaker to the grid. When you go into your breaker box there and it has the main ones, and you turn those off. You do not want to feed electricity. So an old man that I learned a lot, spent a lot of time from when I was as small as I can remember until he passed away. And I guess I was probably, let's see, I was probably in my 30s by that time, maybe late 20s when he passed around. I don't remember the date. My brother would. Anyway, he's Uncle Bruce. That's Uncle Bruce. So Uncle Bruce came to Texas in a covered wagon, And I got an old copper bucket that they used to use on their stove. It's got a round bottom. It's a solid piece of copper, cast copper. And that was on their cook buckets that they use hanging over the fire. And he's from Ohio, and he used to tell me, I'm from round at each end and high in the middle. So, Ohio, that is pretty funny. But anyway, Uncle Bruce taught me a lot of things about mechanics, fixing things, engines, just anything that had to do with messing around in your garage, putzing around doing stuff. He did it. He was a master mechanic, in my opinion. I don't know if he has a certification or anything. I guess he does, because he worked on transport aircraft in World War II. And so then he did that, and he worked as a mechanic in different places. He worked at Humble Oil and Refinery Company down in Baytown, Texas, for quite a while. And he worked on people's lawnmowers and stuff in the neighborhood. And when we were kids, we'd go over there and we learned how to work on lawnmower engines and edgers and anything that had to do small engines. We did a lot of that stuff. When we got older, we did cars and rebuilding engines and things like that. And so I learned a whole lot of stuff with him working on things. And so he was telling me about electricity, trying to teach me about it. So what he did was he said, boy, son, you say son, I'll show you this. And he went over and he got himself a water hose, and it had the pressure gun on it. The kind of you squirt it and it sprays, but it's just a squeeze handle. And you can go buy those at hardware stores. You'll probably know. So he went over and he turned the water on, and then he would squirt a little bit in his hand. And he goes, son, that right there, that's current. And then he took that water hose and he squeezed that handle, and water shot out of there. And he goes, and that right there is voltage. So that's how he explained it to me. And the concept being that voltage can be represented kind of like water. It works very similarly to the way that water piping systems work, where your higher pressure is with the direction the water goes. So if you have more pressure on this tank or in this pump, it's going to push the water through the system. And if you have a water bladder tank that you use you're going to pump it in there, and there's a big old bladder tank is basically a thing that gives you constant pressure if you have a water pump. So what happens is you pump, turn it on, and it fills this tank that has a big old huge rubber bladder inside. And as the water is getting compressed, it keeps on getting pressure inside there. And then as you turn the water on in the house, it just kind of slowly goes down, and it's pretty consistent in pressure. And then when it gets to a certain pressure, the pump might turn back on and refill the bladder, keep the bladder up there. So your pressure, it's going to fluctuate, but you don't really notice it that much as long as you have it set right. But anyway, so water will go to where the higher pressure is. Well, voltage the same way, and electricity. If you have higher voltage, then on one end, like generating electricity, it can be solar panels, it can be anything, it's going to push that electricity the other way. So you have a battery over here that's a low voltage, and you have a solar panel that's a high voltage, and you send it to the battery charger or the inverter. Battery charger basically brings in this, it's a solar type system, solar inverter, and pulls it in, and then it charges it. So it charges the battery because the voltage is higher over here than over there, and then the current flows from the solar panels into the batteries. And the voltage and the controller will check the batteries and make sure that they don't get too much electricity. So anyway, so that's kind of how you think of electricity and how things work with it. So anyway, so the point is that when you're trying to hook up this generator to your house, if you have no electricity flowing in your house at all, and then you plug in your generator into a socket in the house anywhere, that electricity will flow. It'll basically use your house as extension cord from the generator, and all the wiring in your house will become basically an extension cord. It'd be like you took an extension cord and you put three plug into one male in, you plug into the generator, and then it's got a little fan thing with three little female ends there, and you don't get any tranny ends. Sorry, if you're a tranny and you don't like male and female, non-binary, well, don't mess with electricity. You might not like the results. Anyway, so you plug into plugs. You got three of them. So now all of a sudden you got electricity in all three things, but only one source. So that's the same way that it works with you wanting to use your generator outside. So you've got a generator outside. You don't have an electrician installed the feed for your generator, but you do have an outdoor plug. And that outdoor plug is set to a rate of 15 amps. Unless it's something special, it's a 15 amp plug, and it has a socket that looks like that. Exactly like that. That is a 15 amp plug. This piece of equipment right here, this little socket, it can handle 15 amps. You start getting above 15 amps, it'll get hot and melted. So that's why you have a breaker in the house. And then the breaker, if you try to pull more than 15 amps out of that line right there, like let's say you hooked up 2 hair dryers to this same thing, you turn both of them on, the same thing in the house, on full blast at the same time, what's going to happen is the breaker in back is going to throw, because 2 hair dryers typically will pull, a hair dryer tries to pull the max. That's why they sell you 1875 volt watt hair dryers, but you can't run 2 off there or it throws a breaker. And so the reason that does that is because you start getting hot. Breakers are set for as a temperature thing. When they get to certain hot, they throw. When a temperature, so they get hot, they throw. And you keep doing that, and what's going to happen is you're going to keep hitting the peak of what these can handle, and you start having black stuff on here, and plugs, those things will start melting, and it's a bad thing. Even the wires on the back, if the wires on the back aren't secure, wherever they're not hitting real hard, it'll get hot faster. So you want to make sure always that your connections are really good whenever you're messing with electricity. Well, so in your backyard, you got a 15 amp plug. And you've got a generator sitting here. Now this generator has got plugs like that. And your house has got a plug like that. So you can't take your extension cord and plug it in, because you got one end like this, one male in, and one, and well, this is not the right one. I was going to show this to you in a minute. But anyway, one's female and one's male, all extension cords. You go to the hardware store, they're all paid all that way. They are not. I don't even think they can legally sell you one that is male on both ends. They probably can sell you one and female on both ends, and they would call that an extension. But I don't know that wouldn't even work. You'd end up with a female at the other end to plug something else in, and so you could probably use it as a type of an extension if you want to. But anyway, so here the goal is this. The goal is to get that generator to use your electricity in your house to provide at least 15 amps of electricity. So to do that, you create your own extension cord. Now remember, you got to throw that main breaker, because if you don't, that's illegal. You cannot plug in a generator into your house unless it has ability to turn off, or you have turned off the main breaker. And the reason for that is that whenever there's a power outage, the workers are on the line, they're repairing the circuits out there. And if somebody plugs in electricity into the line, it has a potential of shocking the workers, and it could actually kill them. So you don't ever plug a generator into your house unless you know that the main breaker is disconnected, or you have a specific, they make devices that when the generator's running, it will disconnect from the house. And then it sits there and watches it, and if the power comes back up, then it'll switch back off the generator onto the grid power. Now the problem with doing this is you don't know if the grid power came back on or not. And so when you're doing what I'm talking about possibly doing, and I'm not recommending you do it, I'm just telling you can do it. So anyway, you make sure to check the neighbors. All their lights are back on, and you ask them, hey, is your power on? They say, yeah. Oh yeah, it's all back on again. Okay, then you can turn off the generator and then go back and throw your main breaker after you take the generator cable out of the wall. Okay. So you got to make a cable. You can't buy one. So what you need to do is just get you a cable like this. This is not. I got to make something else. So this is what you're going to do. You're going to take and make a cable with 2 male ends on it. Plug one into the house, one into your generator. You do the house first, and it doesn't really matter. You turn the generator off, plug them in, and throw the breaker in the house. For that socket, go and make sure you know where all your breakers are, and throw the breaker that is connected to your back porch line, turn it off. Now you plug this in, and you plug this in, you start the generators. Now the generators providing electricity into the house up to that breaker. But it won't go any further because you throw the breaker in there. And once you turn it, now make sure the main's off. Turn the main off. Turn the main. I'm going to keep telling you that because we don't need any trouble here. And this is what you're going to get if you hook that up to the grid. And you got the main turned off. Then you have electricity up to your little plug. Now remember, you only have 15 amp. And your breaker will throw if you try to pull in the house more than 15 amps. So that means you can't run a microwave and a disposal and at the same time, and somebody turn on a hair dryer, and your refrigerator and freezer, probably two of those is not going to run off a 115 amp line to a generator. It probably won't, and probably because when you have any type of a motor that has a compressor in it, and some of these any type of motor, and it could be a disposal, it can be compressor. When you turn those on, they have a lot more draw of power than what they normally run at. Sometimes as much as 3 times as much. So if it says 10 amps, it might pull 30 for a very short time, just to get the motor started. Well, if your generators don't like that business, the grid system can handle it. It's got lots of power. As long as your breaker hadn't heated up too much, it'll go ahead and start. Anyway, so that's what you do. You just turn on your generator, you get your generator running, you plug it in, you have that breaker turned off, and then you can go in the house and start turning on the specific breakers in the house that you want, or make sure all your stuff in the house is turned off. And if the water heater's 110, make sure that the water heater is not plugged in. If it's a electrical water heater, electric water heater, not now gas water heaters, you can still use them. They got a little stuff in there, and I don't even know. Yeah, they use electricity. So, but not very much, so they'll work okay. Your whole house fan probably will not work. Whole house fans in your central air conditioning systems are running off the 220 that runs the compressor, so that won't work either. But you can then turn on ceiling fans, turn on small lights here and there. If you got LED lights, which I can't stand, then you can use those. That kind of thing. But it's only 15 amps, so you're only really going to be able to, it's going to have limited, but it's better than nothing. It's better than stringing extension cords all over the place and having doors open, especially if you're in the winter. Now, if you're in the winter and you have to do this, you dang sure want the doors all shut, but if you haven't already got this prep. Now, the big deal is you got to make sure you go to the store and you get these little ends, because I made this cable. I went, and this is as you notice, you can see this. I just keep, whenever I have an appliance or something, tool or whatever dies, I cut off the cable, to the appliance itself, and I keep the cord. And I can go make a small extension. I'm going to change this out. I don't want this male. I want a female end on here because I want to make it short, real short. About, I guess that's about 6 feet extension cord. And all it's going to cost me to do it is, a female. I don't have a female one here. I have no, that's not the right one. But anyway, I can get a female in and stick it on here. And then I'll have me a little short extension cord. And it costs a lot less money than buying one at the hardware store. Now, if you're going to do this and you get an electrician, he can go and put you in a circuit where you can actually put more amperage in it. So just all depending on your generator and stuff like that. But the only reason I'm telling you about this is because it's a quick and dirty thing in an emergency situation. And you say, oh my goodness, we got to do this and we don't have any electricity and we're out. And my family all lives down in South Texas, and we have hurricanes come in and stuff like that happens, and so they can be out of power for days. And it's better to have my refrigerator running, freezer, or my freezer running. And you can switch back and forth too. You could, my refrigerator's on this breaker and my freezer's on this other breaker. Well, you want to run the refrigerator for a bit and keep things cold, and then don't open the freezer door. Go over there and flick the breaker, turn the refrigerator off, and turn on the freezer. Let the freezer run for a while. You have to keep doing that, but probably you can keep all your food frozen and your refrigerator food frozen as well as refrigerated for the refrigeration portion. So I want to tell you about 20 amp stuff. So when you see a plug, you may have seen some plugs that look like this. Now you can stick the standard plug in there. Let's just plug, or this plug over here. It goes right in, no problem. This one doesn't even have a ground thing on it. You just stick it right in there, and this is one that's got waterproof stuff in it. Anyway, and there you go. Plugs right in, right? And it had that side thing. Well, let's see if this is the right one. Yeah. So here's one, and look at it. It's different. It's got the little prong there sideways, and it goes in there too. The reason it will is that this is a 20 amp plug and a 20 amp male plug, female and male, goes in the wall. So when you see these, you got 20 amp. Most of the time, if you go back and you check, they'll have a 20 amp breaker in the house as well. And that means they use at least 12 gauge wire on that line. So different kinds of wire, you got different kinds of gauges. And when you're doing things like making your own cable, if you go down and buy them, you're going to have to make the cable. So you're going to have to cut the insulation back. And this little knife, and I just use my pocket knife and just score it a little bit, and I just kind of push it back, and I just kind of work it a little bit slowly. You don't want to cut the insulation on these inside wires. That's what you don't want to do. So you get that insulation off. You clean off this stuff is all going to be in here. I don't know what they call it, but anyway, I call it packing, maybe like that. But anyway, you cut that off with a knife or some dikes. So that's what these are called. Some people call them wire cutters. You know, they're called dikes. We call them dikes. That's what they've been called for years. Until now, all of a sudden they got changing. They're screwing out the language. But anyway, they're called dikes. They kind of look like they got a little dike right there. And you can do these are great. But anyway, you can cut the wire with that. And then once you've done that, you need to strip this off right here. So then you can get wire strippers. Now you can use these wire strippers as cutters too. They got a cutter thing right here, but don't cut anything besides copper with these. And usually this one actually, no, this other one says, yeah, here's one from Klein Tools. Klein makes great tools. And it says right there, don't use copper. It says use copper only to do it. You don't want to dull that knife. It'll steel wire and stuff like that. It's not a good idea to do with these. And these guys have got different little spots here. And what they're for is to put it on there, cut through the insulation, pull it, and you work it a little bit like this, work it a little bit like that, and pull it off, and it'll get it off. Now this wire size is different sizes, and these holes are different sizes also. The smaller number is a bigger wire. It's just opposite what you'd think. 12 gauge is bigger and carries more electricity than 14 gauge. And they have the charts like at Home Depot and stuff. They tell you can look it up on the internet too. What kind of amperage can I run on different ones? Now we're going to talk about that amperage thing here again in a minute. So anyway, you take this. When you get one of these, you buy whether it's this or it's this. One of these. It comes with a little piece of paper inside there, and it tells you how much to strip the shielding here and this off here. So when you're using it and you're installing it, then you go in here and you take. I didn't bring a screwdriver, but anyway, you go in here. I'm going to go get a screwdriver. Okay, so got a screwdriver. So I'm going to take this apart real quick. You guys can see me do that. Alright, we take the screws out. There's always a screw somewhere. Like this one over here had a weird deal. It has a little screw on the side right there. And you take that screw out, and then just this whole thing separates from the yellow from the orange. And so inside you have these little connectors, and this, so you stick the wire in through here. And this has actually got a wire clamp right here to clamp and hold the outside insulation. So if you pull on it, it doesn't pull the wire out of the off the back of these prongs. So it holds onto it so it's stronger. Well, you weren't supposed to be on. Now you're going to make my glasses shine. All right, so we go over here and we undo this. And don't forget to put your base and put the base through here first. Don't forget to do that. I do it all the time. I'm on there, I put the end on, and I go, oh, that's great. And I go, oh, wait a minute, I got to put the base on. So I got to take it back off and do it again. Thinking about too many things at one time. Now, all these plugs come with little screws here. These like a silver one, a brass one, and then this one is old, but it's green. And that's the ground. The silver one goes to the white wire. and the gold one goes to the black wire. Always do it that way. So you can read the instructions, see how to do it, and once you wire it all up, you put that on the end of your wire. And that's exactly what I did to make this cord right here. All I did was take it, since I cut this off a utility, I stripped it, I put it on the inside here, put the end on it, and now I got 2 ends on each end. It's so simple to repair extension cords, and as much money as they cost, don't ever throw away an extension cord unless it's just really damaged back. There's no reason to do that. Okay, I wanted to talk about voltage for one last thing for this video. Voltage and amperage, and how do you compare the difference in watts? What's this watt business? So you know, you got a 100-watt light bulb. You're going like, well, why does it say watts? But my stove or my other utility, my hairdryer, it says the hairdryer says watts too usually. But if you look on the electrical thing, it doesn't say watts. It says usually it'll say amps. So watts is the amount of energy that's being used. The absolute, it's like universally convertible from amps to watts. So volts times amps is equal to watts, and it doesn't matter what the volts are. So if I take 12 volts times 100, let's see, 12 volts times 1 amps, then that's going to be 12 watts. Okay. And it doesn't matter if it's DC or AC. So if I have a 12 volt battery and I'm going to hook up a let's see, 10 amp device to it, well, 10 amps at 12 volts gives you 120 watts. It's the same amount of energy that a 120 watt light bulb would be used in your house, but it's 120 watt in the house on the AC, which is 110, which means you take the watts and divide it by the volts and get the amps. So that's how you do it to get a comparison of energy. So if you're trying to, especially if you're trying to do off-grid stuff, you want to know, well, how much, this says watts on my generator, or it says so many watts on my solar panel, or whatever. You can calculate, well, how much juice these devices in the house are going to be used by converting everything to watts, calculate it out, and figure out what you're going to use. Now, when you change from one type of electricity to the other, like, for example, from house power at 110 or AC power to DC power, for example, you lose energy in the form of heat. And the longer the wire is, the more energy you're going to lose also in the form of heat, which is why the big major power lines out on the street are really high voltage, 4,000 watts, volts or something. And they use the transformers, and what those do is they reduce the voltage down to what your house can use, 110. 210 legs to make it 220 circuit. So that's what that's all about. And hopefully you guys, oh, I wanted to show you one more thing. Get one of these. They're cheap. Whenever you're messing with electricity in your house, you plug this thing in. If any of the lights come on, there's electricity there. So don't screw with it until you plug that in and there's no lights. This detects wiring faults. If you do them wrong, then the different lights will come on depending on what you've got wrong. But as far as you're concerned, whether there's electricity or not, just make sure that it's there. But if you don't have one of those, get you a fan, get you a hairdryer or something, plug it in the circuit, turn it on, see if it comes on. If it doesn't come on, you're good. It doesn't mean that there absolutely is no electricity, but there probably isn't. Especially if okay, I threw my breaker and it was working, now it's not, you're good. So just do that. So anyway, the wire cutters are not necessary. You can use a pocket knife. And so instead, it's kind of messy, but it'll work. And I hope you guys have learned, I hope you got some use out of this little video, and y'all have a great day.